So somebody, I believe, asked if this is the right Zoom meeting. If you're looking for the level one ABC electrical apprenticeship e-learning teams meeting, you've come to the right place. So we'll give it just a moment or two here because I can see there's some more people, I think, dropping in. This is a very big class, as I've said before. So um, this is probably going to be a big teams meeting. Tonight, it was actually my hope to have a special guest, Miss Jennifer Bozick with Vincennes University, and she still may drop in here. She got the link to it, I think, kind of late, so that's really my bad. But if she doesn't make it into this meeting, we will make arrangements for her to be in another meeting, and we can discuss the opportunities that there are for you guys to actually be able to not only complete our ABC electrical apprenticeship, but there is also an opportunity for you to be able to complete and receive an associate's degree from Vincennes University. That is something that actually just very, very recently that we have had come to being. Been some negotiating going on with ABC and VU, and we were successful. So looks like that's coming about. Let me see. Okay, great. Well, looks like she's supposed to be logging in. Looking around here at the names, I don't see her in here yet. Looks like we're up to about 45 people. It is also my intent tonight to, which I assume you can see the other screen where it has Unit 15 parallel circuits on it. I was intending to do some teaching tonight too, and have the opportunity to really start kind of digging into this, as we say. So, um, give Miss Jennifer a minute here. See if we can get her on here. I want to get that taken care of first. I hope that everybody has their books by now. Surely by now everyone has their books. I can't say that I am aware of anyone who does not have their books or has not been shipped their books somewhere. So I'm assuming that's all taken care of. Just kind of while we're killing some time here, I am in discussions with, yep, this is the right one. In discussions with Mike Holt Enterprises, and I believe we're going to be able to streamline our book shipping through Mike Holt Enterprises. So, you guys already got it squared away now, but next year when you get your books, they will be um, coming directly either to your contractor or to you. And what's been happening is they'd have to come to us, and then we had to repackage them. Um, and Now we'll be able to ship them directly from Mike Holt. And I'll say this now, I can't type any messages in the chat because right before I fired this up here today, I realized make a long story short, I got a keyboard, but it's not connected to my laptop. So I got a mouse that works, but that's it. So you're going to have to just hear my voice. I thought somebody was asking a question, but I'm not seeing it. So um, I don't see Jennifer. Jennifer, I assume if you're there, you'd say something. It's a really long list of people, so it's hard to catch all the names. While we're waiting, I have no idea because there's a whole lot of there's a whole lot of icons. If you've ever been in a Zoom meeting and saw that, there's a whole lot of them on there. Presently, I believe I counted this morning or yesterday actually, 32 people who have not started their work in Capacitor yet. I have no idea if anybody in this meeting is actually one of those people, but um, need to get on it. In case you're not aware, today is October 20th. The work that's available and open on the capacitor now is supposed to be done by December when we break for Christmas. I want to say that was December 11th. Don't hold me to that date, folks. I think it was that date, but it's, like maybe the second weekend of December, something like that. That's when this semester ends. All of the work that's been released to this point should be done by then. And then I will release the second semester work in January. Um, I'd also want you to keep in mind that there's going to be other work. You see the workload that's on there, so to speak, or the assignments. I am going to be doing some other interactive stuff. Probably the next session that we have on our schedule, which it looks like is the 17th of December, is our next Teams meeting. I intend to do some lab-based stuff. So I intend to do some stuff that's a little more lab-based. We're going to be talking about the branch circuit wiring book, and I'm really starting to dive into some of that. So, um, yeah, I am obviously stalling because I'm waiting to see if our lady from Vincennes University is going to get on there. She said she was going to be jumping in, but um, haven't seen her yet.
Mike, can you hear me?
Hey, there she is.
Sorry,
Hello.
I'm having issues with the camera, but I am here.
Okay. Well, I can hear you, and I believe everyone else can hear you. So, do you want to go ahead and try to go over this?
Yes, please. I would like, is it possible for me to share some stuff?
Well, let's see. Can you? Or I mean, I've got something I'm sharing right now. I'll kick out of that and
Okay.
see if you can. Can you do that from your end?
Yeah, I'm looking right now. Maybe Teams. Sorry, I know there are a lot of system issues going on today with Amazon services, I think, having.
Yeah.
Okay, here we go. It says only meeting organizers and presenters can share.
So, I wonder how I would change that.
Well, I can throw some things into the chat maybe.
Okay.
Let me see if I can do that. And then everyone can kind of look at that stuff. Maybe.
Who can present? Oh, here you go. I'm going to put it to where I had it set for just me. I'm changing the setting to where everyone can present. So,
okay.
now everyone, we just want Jennifer to present. So, there you go. Try it again, Jennifer. See if that helps you.
Okay. Still showing the same.
All right. Well, I already tried my best trick, so.
That's okay. That's okay. So I can go through, Mike, actually what I can do is I can email this over to you real quick, this information. I'll just attach the documents, and then if you can share them with everyone, that would help. And it doesn't necessarily even have to be right now, but I will go through this information with them.
Okay.
Okay, that has been sent to you.
Okay.
So while you're pulling that up, I'll just kind of start and I'll introduce myself. My name is Jennifer Bozek. I'm Director of Apprenticeships for Vincennes University. My office is actually located at ABC at the headquarters in Indianapolis, but I do travel across the entire state of Indiana running the program for Vincennes. And so I wanted to hop on and share this opportunity with you all tonight and just kind of tell you about the ABC VU partnership and what all that brings for all of you, actually. So ABC and VU have been partners in education for over 20 years now. And when they started this program, all those years ago, they started with an associate's degree. And so it's evolved over the years and the way that it is laid out and everything. But for those of you who have never taken a college course or looked at a college degree, a college degree is laid out in two pieces. Basically, you have your major program requirements and you have your general education classes. And so when they built this degree for ABC apprentices, that's what they did actually. They built it just for ABC apprentices. And it evolved now, and so that it covers all apprenticeship or all apprenticeshable trades. So this one degree not only covers electrical, but it also focuses on plumbing, carpentry, et cetera, et cetera. But the degree is a 60 credit hour associate's degree. And what happens is, on the copier, is VU awards ABC apprentices up to 36 hours of credit towards this associate's degree, just based on the work that you all are already doing in your apprenticeship classes and on the job. So when we look at it, that's what your major program requirements are those 36 hours of credit that are coming from your apprenticeship program. So you're already putting in more than half of the work towards an associate's degree, and that leaves you with a remaining 24 credits to complete for that degree. Those 24 credits are actually broken down into 8 classes. And so, and I don't know, Mike, is this level 1?
Yes, this is a level 1 class.
Okay. So as a level 1 apprentice, starting off, what I would do is take a look at this degree and say, okay, I've got 8 additional classes I have to complete on top of the apprenticeship work I'm already doing. And those classes divided out into the next 4 years could be done 2 each year, and you could come out earning an associate's degree. So the biggest piece of all of this, which is great for you all, is that this degree is completely free. So there's 0 tuition charges to any of you for taking these classes and earning this degree. So Mike has listed up there the 8 classes that I'm referring to. So, and it's the basic general education classes: English composition, apprenticeship math, financial management, personal financial management, interpersonal communications, business ethics class, earth science with lab, environmental science, and then of course first aid. And so some of you may have seen this year through emails that we sent out registration for that Health to 11 class. So we'll talk about that in a little bit, but that is one of the course requirements for this degree. So not only are all of these classes tuition free for you guys, but we also make them available completely online, which means there's not a time where you have to come into class to physically show up and take this class, or like be on it, 5 o'clock or whatever. And we also provide textbooks to students once you're enrolled in the courses. So for example, English composition has a couple of textbooks. So if you would enroll in that course during one of our semesters, I would mail you those books. You could use them for the semester and then you just send them back to us. So it's kind of like a library cycle for that. But again, overall, this degree is an Associate of Science degree. Your major is in technology apprenticeship, or what your trade actually is, which is electrical. So that's your main focus, is accumulating those 8,000 on-the-job training hours that are required for your apprenticeship and making sure that you get those submitted to ABC. And then we articulate credit for those hours. And then in the meantime, you would take the general education classes online in the summer semesters. So these classes, those 8 classes that are listed there, are offered, like I said, online. Primarily, we offer these courses in the summer semester so that it doesn't interfere with you taking your apprenticeship classes in the fall or spring semesters. And during the fall and spring semesters, we do offer one of those classes, which is probably the least intensive class that we have listed here. And it has a test out option, which is why we offer it. So I'll kind of go down to that Health to 11 class just real quick. I don't know if anyone was able to enroll in that course, but the requirements for that course are that you have to have a valid first aid, CPR, AED certification, which I'm under the impression that you all get for as part of your apprenticeship anyways. And if you don't, then we can discuss ways that you could potentially earn that. But you have to hold that certification, and then you can enroll in the course. The courses are held online for 8 weeks. So this particular course just started last week. We will offer it again in our second 8-week session in the spring and also in our summer semester. But the class has a test out option, which means that the instructor would offer you a test. If you complete that test and you pass it, then you only have to do the written assignment for the course. And then you'd earn the 2 credits. And that's kind of like a shoe-in for you to get started into your apprenticeship classes and to start earning that credit towards your degree. So that's, and we can provide you all this information in an email. And then if anyone has any questions, I'd be happy to answer them at the end. The other option that we have is new this year for apprentices at ABC, and that's a certificate of graduation. It's in the same major. So the focus, once again, is all on your ABC apprenticeship and earning those on-the-job training hours. The difference is just the requirement of credit hours. So for this certificate program, it is 24 credits that you would need to earn as you accumulate your on-the-job training hours. And the remaining 6 credits come from any of those general education courses that are, again, listed on the screen. So you can do a combination of any of those as long as it equates to 6. Again, these are offered in 8-week semesters online, primarily summer semester. If anyone has transfer credit, we do accept transfer credit. So you could transfer as much credit from as far back as you would want to, and credit does not expire. And so in order to do that, you would just need to go through the proper process of requesting an official transcript from the school you attended. Also, we accept military credit as well. And so if you are a veteran and would like to transfer in military credit, you could get with me, contact me, and then I could walk you through that process of getting those transcripts over to us as well. With transfer credit, the only thing that I will point out is that VU does have a residency requirement for the associate's degree. So you have to meet at least 15 hours of credit with Vincennes University to earn an associate's degree. So you could transfer in as much credit as you would like, as long as you are still taking 15 hours with Vincennes to earn the degree. That can all be done, like I said, through the proper process, official transcripts. You go back to the school you attended, request an official transcript, and have it sent directly to Vincennes University. And it can be sent to the main campus records office. Or if you need further information, you can always reach out to me and I can provide that as well. And then I also want to share with you the academic calendar for this year. So for the fall semester, like I said, we had that online health class, and we'll do the same for the second 8 weeks of spring. But the large semester happens in the summertime. And so that calendar, thank you, Mike, is pulled up here on the screen. So that shows you that we'd like to have all official transcripts submitted by the end of this semester. That way Records has time to evaluate those and get them noted onto your record with VU. There's also an AccuPlacer requirement, and that is a placement test that everyone must take unless you have transfer credit in lieu of that. That would be a case-by-case basis, but an AccuPlacer is an online placement test and must be completed before classes begin at the end of May. You are still able to register for classes without having taken the AccuPlacer, but it has to be completed in order to begin taking courses. So because these are all online, we have an online registration process, and that is emailed out to everyone We also send out text messages and stuff for information. So please make sure that all of your contact information is up to date with ABCs, because that's the information we will be sending it to. Online registrations will be open for a month in March. And then we take time to go through, finalize your schedule, get those all back out to each individual by April 24th. And we send out the textbooks that follow classes begin the last week of May. As I said, the classes are 8 weeks online, so they would run the end of May until just about the end of July. There is one 10-week class, which is the Earth Science class with a lab. Because it's more credit hours, it does require a longer duration for the class, and so that one is 10 weeks, and that would go until just about the second week of August. Once again, and these courses that are associated with this degree are tuition free, so it's zero cost to you guys. We provide you the textbooks as well. It's a great opportunity. These are stackable credentials, so if you would like to start, you could earn, start with the certificate program. You could start with that into the associate's degree program. We do also have a bachelor's degree, which is part of it. It's kind of built off of this program, but it is not tuition free. So the bachelor's program is in construction management. Again, it's online, but you would have to look at alternative funding sources for that or pay out of pocket. If there are any questions, I will leave it open now.
Anybody have any questions? There are quiet bunch.
What would the general rough estimate of tuition for that bachelor's one look like?
So that's a great question, actually. I will say this, that if you, to get to that bachelor's, you'd want to earn this associate's degree first. It's kind of like a step into that program. So that would complete 60 hours of the 120 that are required for that bachelor's degree. And then if you look at our tuition rates, I want to say right now you're looking at about $275 a credit hour. So you'd probably be looking at somewhere between $16,000 to $19,000, depending on, you know, tuition rates at the time you took the courses and cost of textbooks and stuff like that. But considering that's the total for a bachelor's degree, that's for anyone who's taking college courses, that's very good.
What's the name of the associate degree again? The major name you said when you complete it?
The major name is called General Studies Technology Apprenticeship.
Okay, because I already have a bachelor's in construction management, so I was just wondering if I can just continue and do my associate as well. I guess I don't know.
Yeah, I mean, we could definitely, if you would want to transfer in credits, you could definitely take a look at doing that, and we could talk more offline about that, and how you could get those official transcripts in and stuff.
Okay, perfect. Because I already completed my degree. Maybe I can transfer some credit and just earn the associate as well. Why not?
Yeah, definitely. Just shoot me an email. And actually, it's up on the screen right now that Mike is showing. All my contact information is there, and my email is also included.
Perfect. Okay, thank you.
Mm-hmm.
I've got a question.
Sure.
So I've got a bachelor's also, but it's in electronic engineering technology. And would some of you said that you can transfer for the associates? and you can also transfer for the
for the
bachelor
bachelor, that
if that's
if
what we
that's what
wanted,
we
if I,
wanted.
if that's what I wanted to do,
Hmm.
and I could transfer with you said it was $18,000 or something to get a bachelor's. You think I could get a lot of the credits from that school to transfer over to bring that down to something more reasonable? Or
Yeah, so one thing I will say is like it's transfer credits is all dependent upon like the schools, and as long as it's an accredited institution, then majority of the general education classes should transfer over. And then major to major, we would have to see, what classes specifically were in that major, and if there's any way that those would transfer in for this major, or potentially do like course subs and stuff like that. A lot of your transfer stuff is going to go on a case by case basis. So we would need to get official transcripts submitted so that we could look at what transfers, and then, do a degree plan for you to show how that would all be laid out.
all right, thanks.
Mhm.
Just to make sure, you said email you about that. I have a mechanical engineering degree as well already.
Yeah, if you guys have questions about wanting to earn the bachelor's, and you have or the associates, and you have transfer credit, if you want to email me, I can send you that like process of how you go about starting basically that process of getting transcripts sent to VU, and then like our next steps and stuff.
Do we have to complete the program first, like the APC program, the certifications, to do the
No.
associate?
No, you don't actually. You can do this concurrently. So you can be earning credit for your apprenticeship associate's degree, while also, completing your apprenticeship, completing your associates. Yeah. And then we can also take a look at if you're interested in the bachelor's. Now, for any students who are wanting to go straight to the bachelor's program, understand that we would need to make sure that there's a clear pathway as far as like you're going to earn this associate's degree, so that you get those credits, those 60 credits from this degree to transfer into that bachelor's program. And then we would stack into the bachelor's program. And then we would also want to take a look at any of the transfer credit that you have from other institutions, and how that would apply towards that bachelor's degree as well. The one thing I will say is that because the associate's degree is tuition free, for funding purposes, you would not be able to take any of the general education classes towards the bachelor's degree in the summer semester. And that just comes from a financial aid funding reason, because the classes for this associate's degree program are tuition free. So once you complete the associate's degree, then it's kind of like open, and you can take classes fall, summer, spring semesters. But until you complete the associate's degree in this program, then you would only be able to take the classes for the bachelor's degree in the fall and spring semesters. But we do have a lot of options for that. I mean, we have 16-week semesters, 16, 12, 10, and 8-week semesters.
Great. Anybody else have any questions? All right.
If anyone has any questions, feel free to reach out to me directly by email if you'd like. And I'd be happy to answer any further questions that you guys have.
Fantastic. Well, Jennifer, thank you so much. And we're going to do this again tomorrow night at the same time. And I believe all those links were in that email. If there's an issue with any of that, please let me know.
Okay,
So,
perfect. I will. Thank you so much.
very good. Thank you.
Bye.
All right. Now let's get back to where we thought we were going. Okay. Yeah, folks, that is an outstanding deal. And no two ways about it. So if you were looking to achieve a college degree, that is a fantastic way to do it. And VU is very flexible, for lack of a better term, as far as the what I have seen with other students as far as the gen ed courses. And if you have previous college experience, a lot of that stuff will oftentimes play a role in making your experience minimal as possible. So to be respectful to everybody's time, I'm going to continue on with this, and I want to start in Unit 15. This is, as I've said several times now, this is a big class. There's probably people all over the road as far as where you're at and some of this learning. So first year is essentially really some 3 to 4 major subjects: safety, electrical theory, and then at a certain point we will introduce the National Electrical Code, and that's where we're really starting getting into that at a higher level. And also the subject of branch circuits. That will be more than likely our next session. But I do want to get into, decided to pick on parallel circuits. If you've been moving through the material, we started in August, so if you're moving through the material, you're either well past this or at least on top of it. And I feel like that out of series circuits, parallel circuits, and combination circuits, parallel seems to be the one that, as an instructor over the last 15 years, I feel like that typically is the biggest question mark. I used to think that it would be combination circuits when I first started teaching, and as it's really turned out, it seems like parallel is it. And parallel is, I'll say, predominantly the type of circuits that we're installing as an electrician. So I want to jump into this and see if we can't get this wrapped up and try to keep these sessions at about an hour. We may run a little bit long today, so sorry. So parallel is a term used to describe a method of connecting an electrical circuit so there are 2 or more paths through which current can flow simultaneously. And a parallel circuit has different characteristics and calculations than a series circuit. So in this unit, we're going to talk about the relationship between resistance, current, and voltage, and the voltage of parallel connected power supplies, common applications of parallel circuits. So it's a great graphic or picture here to kind of explain how a parallel circuit works. Parallel circuits are like a river that's been divided into smaller streams that come back together once again. And in a parallel circuit, the voltage across each component of the circuit is equal to the voltage source. So in other words, the voltage across each one of the components in a circuit will be the same. In other words, in a 120 volt circuit that is providing power to all the receptacles in the room that most of you are probably sitting in now, all of those receptacles more than likely have in the neighborhood of 120 volts. And I say in the neighborhood because there is a nominal voltage rating that should be entering into any building. So you might be 118, you might be 121, you're somewhere in that neighborhood. But all of those receptacles on that circuit, or the outlets for lighting in the room that you're in, should all be the same voltage. And the reason being is the graphic you see in front of you now. You cannot have a circuit that starts out at 120 volts, and by the time you get to the last plug, it's only 90 volts. Well, that computer or refrigerator or whatever you're plugging into that circuit is not going to operate well on that. And here's a little quick example. The 240 volt circuit has 3 15 ohm resistors connected in parallel. So the voltage across any one of these resistors, the voltage, by the way, is 240 volts because the voltage should be the same throughout that entire circuit. Now that is discounting the fact that if there was an extended length in this circuit, then you could have what is known as voltage drop. So in other words, you get to the farther length of it, you might have a voltage drop that would exceed the tolerance rating for the nominal voltage and perhaps damage equipment if you had not accommodated for that in the conductor size. And here's another one. 24 volt circuit has 2 5 ohm resistors connected in parallel, and the voltage across one of these resistors, of course, is going to be 24 volts. A parallel circuit has 2 or more paths through which current can flow simultaneously. And some primary definitions that you need to be familiar with are, well, first of all, right in your Uglies book, if you have one, and I strongly recommend you get one if you don't have one. That's not the book that we provided, but They're $20. But in a series circuit, there's only one path for current to flow. In a parallel circuit, there are multiple paths. In a combination circuit, that circuit has both series and parallel characteristics. 3 good definitions. And here we have Kirchhoff's current law, which states that the total current of a parallel circuit is equal to the sum of the currents of all the parallel branches. So current in a parallel circuit is additive. You just add up the ampacities as they're showing in this graphic here. And that's why I'm going through some of this kind of fast. Once you've determined the ampacities of all of these resistances, or all of these loads is what they are, your total would be 20 amps. Each one of those 7.5, 9.2, 3.3, so on and so forth. So a circuit has 3 15 amp resistors connected in parallel, and the current of this circuit is 45 amps because you simply add the ampacities together. Now, this is a very important slide. You might want to take a picture of this or write it down, or it's in your book. There are 3 methods for calculating the total resistance of a parallel circuit. The first is equal resistance method. The other is product over sum. And the third is the reciprocal method. So the total resistance of a parallel circuit is always less than the smallest individual branch's circuit. So as you're calculating parallel circuits, whenever you come up with your answer, a great way to check it is go, okay, what is the smallest resistance in this circuit, and is my answer less than that? That's just a quick check method. But whenever you're calculating it, whatever your total resistance is in that circuit, whatever the lowest amount is of the individual resistances, your answer should be less. When all components of a parallel circuit have the same value, this is the equal resistance method, the resistance can be determined by this formula, and it's R total. And if I was writing this out, it would be R total divided by the resistance of one of the resistors divided by the number of resistors. And I'm sure they give us an example here. So, for example, the total resistance of 3 10-ohm resistors connected in parallel is, you're going to take, out of those 3, they're all 10 ohms. So you're going to take one of them divided by the amount of resistances, which is 3, and that gives you a total of 3.33 ohms of resistance. The total resistance of 10 resistors connected in parallel. So here's a circuit, and this again, if you look at the drawing here or the graphic, there are 10 resistances. They are all 10 ohms. So they're all the same, equal resistance. And you take 10 ohms divided by how many of them? 10 will give you 1 ohm. That is the total resistance of that entire circuit. A 240 volt circuit has 3 resistors in parallel with R1 is 15, R2 is 15, and R3 is 15. The resistance of this parallel circuit is 15 divided by 3, of course, is 5 ohms. Simple enough. Now, a circuit has 3 20 ohm resistors connected in parallel, and the resistance of this circuit is, again, 20 ohms divided by 3 is going to be, of course, 6.7. And I am kind of going through these fast because I'm trying to be respectful for your time, but also these same problems, I believe, are in your book. And as you're going through this material, not only are you going through and seeing this in the book, you also, if you watch the videos that are included in these in your materials, again, you have more than likely Mike Holt explaining it. Now, the product over sum method is used to calculate the resistance of 2 parallel resistors of different values, as determined by the formula RT equals R1 times R2 divided by R1 plus R2. So this is really unequal resistances. So our example here, of course, is going to be 2 resistors. So we have one resistance of 16 ohms and one resistance of 13 ohms. What's the total resistance? And here's our calculation. You're going to take 16 ohms times 13 and then 16 ohms plus 13, will be 208 ohms divided by 29, which will give you 7.2 ohms of resistance. Now, here's the one that is the catch-all, the reciprocal method for determining the total resistance of a parallel circuit. You could have used this formula on any of those. These are just a variety of ways to be able to do this, the three benchmark ways to do these calculations. So the total resistance of a parallel circuit is used when there are more than two resistors of different values. So this, as you can see, notice where it says 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3, and then dot, dot, dot. There are going to be as many resistances in this circuit as you want. You remember seeing the circuit we saw earlier that had 10 resistances. You could use this same formula for that. You'd come up with the exact same answer, but you could use this same formula for that. So what is the total resistance of 16, 13, and 36 ohms in a parallel circuit? Here's our parallel circuit. Here is our formula. And here's where we're taking 1 divided by 16 plus 1 divided by 13 plus 1 divided by 36. There's the answers you get for each one of those. You add all of those up, and then you have to take the total of that, which is 0.1672. 1 divided by that gives you a total of 6 ohms of resistance for that circuit. Notice again, the lowest resistance here is 13 of the individuals. The lowest resistance total is 6 ohms, less than that smallest one. Let's see, a circuit has 3 parallel resistances, 15, 30, and 45. And again, we have our same calculation. And ideally, some of you guys probably get this, some of you guys may take a little bit more, but if you'll go through these and simply take your calculator and work your way through these problems. I know I'm giving you the answers, but if you take your calculator and work through these problems, that's the easiest way to kind of get it drilled into your head. A parallel circuit has the following characteristics. So it has 2 or more paths through which current can flow. The second note is the total circuit resistance is always less than the smallest component. And note number 3, the current is equal to the sum of the current of all branches. And note number 4, the voltage is the same across each parallel branch. So, when power supplies are connected in parallel, the voltage of the parallel connected power supplies remains the same. So here we have, and this is a graphic that you're going to have to kind of study a little bit, how they're actually connecting these batteries together. And then we have a little caution for you. I like they throw this in here. When jumping a battery in parallel, place the red cable clamps on the battery's positive terminal and the black cable clamps on the neg. Pay close attention when terminating the cables on batteries to avoid causing a short circuit. Yep. Connection which could lead to an explosion. Not good. Okay, so some practical uses of parallel circuits. Parallel circuits are commonly used for wiring receptacles, lighting, appliances, and equipment. So here we go. Here's some practical application here. So notice, first, each one of them, they have 120 volts, right? Also notice, while we're on this, we're looking at 3, what I would call general purpose receptacles. So we have a hot and a neutral coming in. Of course, you have a power supply coming in and a neutral coming in. Notice how, first of all, especially because I know I have a bunch of commercial guys on there, if you've got into this, they're using all of the terminals on the receptacle. So they're feeding in power supply coming in and then power supply going back out, going to the next one, go back out and the next one. The typical installation procedure for commercial application would be not to wire it like this. I would say this is more of a residential application. Typically in residential, you're installing receptacles. You are using probably 4 wires and connecting 2 neutrals to one side and 2 hots to the other side. And then, of course, your grounding conductor, which they're not even showing here. But if you were in a commercial application, what you would do is tie the neutrals together, make a pigtail, and go to the receptacle. Tie the hots together and make a pigtail and go to the receptacle. Why we do that? Because here's the analogy. Let's say you're working on this receptacle and it's wired like it is on the screen here. And downstream, we have a computer plugged into it. And you're replacing a bad receptacle. So you take this out. If you were to take the neutral, the feeding neutral out of this circuit before taking the hot, there's a distinct possibility that you could actually cause a backfeed downstream, and it could damage any sensitive electronic equipment like a computer that was plugged into that. I have seen that happen. I saw a guy once that took a joint apart up in an attic, and he took the neutral apart first. It backfed down, and I believe the contractor, fortunately I didn't do it, but the contractor that I was working for, as a result, ended up buying the customer a new TV, a new microwave, and a new VCR. That's how long ago it was, right? But the reason that happened is because when he was taking a circuit apart live, first of all, should have turned it off, but didn't. Secondly, took the neutral apart first, and that, just like the analogy for how electricity works is just like water flowing into a sink. If you clog the drain up, what's water do? It just keeps running into that sink. With electricity, kind of the same principle. It's going to keep going. If you disconnect the drain, so to speak, which is your neutral, then yeah. With sensitive electronics, you can damage equipment that way. Lighting. This, by the way, ladies and gentlemen, is what's called festoon lighting. Some of you might even have this on your back porch. I know just about everybody except me in my neighborhood has festoon lighting on the back porch. So it says lighting is connected in parallel and each light will have the same voltage. The analogy with older Christmas tree lights is with series circuits, you had one bulb burn out and the whole circuit would stop working. And then you had to figure out which bulb that is. With parallel, because there is a pathway, the return path, how a parallel circuit is wired, that's not a problem. That's why we don't have lights that stop working in your house, because they're in series. With everything's wired in parallel, so you don't have that problem. They've also started making Christmas lights that are, guess what, wired in parallel. Appliances and electrical equipment. So appliances such as heat strips, this is examples of parallel circuits. Appliances such as heat strips, water heaters, and some types of motors have their internal electrical components connected in parallel. Later on down the road, we get into motors, we're definitely talking about series and parallel connections to motors and high voltage versus low voltage. That's a whole nother subject. But in the depiction here, they're showing you the elements in an electric furnace. Depending how those are connected, depending on how they actually radiate heat. I'll say that. One advantage of parallel circuits is that if one branch of the parallel circuit is open, the voltage is still provided to the other parallel branches. Pretty much only explained that. So yeah, you can lose one branch, the circuit's still going to work. Parallel is a term used to describe a method of connecting an electrical circuit so there are two or more paths through which current can flow simultaneously. A parallel circuit has different characteristics and calculations than a series circuit. All right, and that is the end of our teaching segment here, or this particular PowerPoint. I'm going to jump back for a second and show you something in capacitor I want to make sure that everybody's aware of. First of all, here's the book selection, and I go all the way to the bottom. This is where we're at right now, Understanding Electrical Theory. And again, notice on there, the book is in there in electronic form. Presentations, that's where I just came from. And then there are videos on all of this. So if you want to go through and catch any of those, that's obviously going to be to your advantage. But all of the PowerPoints that are provided for this, these are what I use in the day-to-day classes that I'm teaching. Because we're only having limited contact like this, I'm doing certain segments to make sure that I catch the ones that I feel like are most important. But as you can see on the screen here, there's series circuits, which is Unit 14, 15, which I just did, and then series parallel circuits. Be sure and focus on those three segments. Look those over good. You need to have a working understanding of basic theory, because as we move forward, when we get into just really sizing basic circuits, branch circuits, having an understanding of how all of that works, you're going to use that and the power wheel. You're going to use that and those formulas to actually determine that. Well, later on down the road, when we get to motors, you're going to use things that are on this power wheel to determine that. We'll eventually get into branch circuits and feeders. You're going to use those same calculations, only we'll say with bigger numbers is kind of how it works. So keep that in mind, and you want to make sure before you move forward and that you make sure that you have a good understanding of those three components: series, parallel, and combination circuits or series parallel circuits. So use the materials that's provided here for you. Our next segment, which I think I'd said it's the 17th, 11/17th. The next segment, we are going to be discussing branch circuit wiring and switch control. So I would tell you this in advance. You should make sure that when you come to that meeting, you have the branch circuit wiring book ready and available with you. Make sure that you have some colored pens, markers, or pencils. What all colors do you need? Well, I'll say this. You can buy a book of pencils for $1 at Dollar Tree. Well, might not be $1 anymore, Dollar Tree. It's pretty cheap. But you following along in the branch circuit wiring book and being able to trace out those circuits will help those who need that to make sure you have an understanding of how basic branch circuits work. And we intend to dive into that and make sure you understand. We'll get into the basis of equipment grounding and the basics of branch circuits. We'll also, as you look on the screen here, we have other subjects coming up: inductance, capacitance, motors, generators. All of these are all very foundational. So I want to encourage everyone to not rush through this material. There's enough material in there for you to get your R's, to have plenty of information. And between that and these meetings, my goal is to make sure everybody gets everything and gets their money's worth, as they say. But if you rush through this just so you can check the box, then that's gonna end up hamstringing you, as they say, a little bit further down the road when we go to the deeper things. Okay. So, does anyone have a question for me today before we dismiss? Yes, Sharon.
Yes. I was just looking through the things that I received. You said there was a chart that we're supposed to have, and it sounds like a book that maybe I don't have.
If I was talking about this, the Uglies Electrical References book, perhaps I'll hold that closer. This one actually is a 2020 version. Should be 2023. That is not a book that the ABC provided. I want to be clear in that. That's not a part of the book set. Here's why that book is important. And I know you might be going, well, why didn't you give it to me? Well, that's a good idea. The books they're not provided in the Mike Holt book set. They do not provide that. There's a whole lot of other information there. But that book, you can buy it on Amazon probably today for $20. What's in this book, and thank you for asking, by the way, what's in this book, in the first 2 to 3 pages, explain everything I just explained: parallel circuits, series circuits, combination circuits. You can use this book when you're taking your journeyman's exam. It's allowed in the testing center. Along with that, there's other tables and charts, formulas. The farther down the road we get with this and we get into some of the more complex formulas, you don't have to memorize those. This book is allowed in there. They're all in here. Anything you need in that regard, you don't have to memorize that stuff. It's in this book. That's why it's important. And yeah, I'm not going to disagree with you. It probably should be in the book set, and maybe it will be in the years to come. We're really kind of in a coming together with the Mike Holt group as far as distributing our books. Maybe that's something in the future we can work on. But for now, yeah, you can kind of take care of the situation and get one in front of you, and it'll help you in your studies. If you can take this in there between this and your code book and what you will get out of the learning that you have here, I believe by the end of the second year, you absolutely should be able to pass your journeyman's exam. I truly believe that, and I've proved it many times. Thank you for asking. Anybody else got a question?
Thank you.
Okay. Be sure and be watching for notifications from me, because you'll get, whenever I send out a message, I send it out through what's called Flashpoint. And I send a message out, and it will go to your email, and it'll be a text message. But, I may send an email out that says, hey, watch this video. I think there's a big misconception of a lot of people that have been through this program so far that it's like, man, if I just go through there and do all this work, I'm golden. my goal is that I'm going to keep throwing stuff at you. I want to make sure not to just give you busy work, but I want to make sure that you're getting your money's worth out of this and you're getting everything you need to know. So there's other stuff coming. Don't think that it's like, well, if I just check the box on this, I'm good. And if I send you a notification that, hey, you ought to check out this video, do it. I may send stuff through Capacitor, but most of the time I'll probably send it through Flashpoint. I'm actually, and I think I mentioned this in orientation, my YouTube channel, which is Electric Lab, there's some videos on there now. I'd say within the next 3 days, I've got some new ones that are going to be uploaded probably within the next 3 to 5 days. Let's say that. And some of those will be helpful also. And there's some more that are going to be done. So those are also in addition to the material we're providing here. Okay. And I know I've got a kind of a mixed bag. I mean, I know tonight we're finding out, we got a few guys who've got engineering degrees and stuff like that. And I understand why you're in this program. And some of this may be very entry level, but also at the same time, some of you are actually moving through your apprenticeship and working towards licensure and becoming a full-blown journeyman or journey person. And, we want to make sure that despite the fact that we're in an e-learning type environment, you can still achieve your licensure, get all the information you need. And we learned tonight, big time, you can have a college degree out of this deal and it didn't cost you a dime extra. So that's what we're offering here at the ABC today. Okay. All right. Hope you guys have a great evening, and I will see you again. If I don't see you before then, I will see you on the 17th. Thank you very much. Huh. Oh, terrific.